It is generally not acceptable to mix wire sizes on a branch circuit due to safety considerations and compliance with the National Electrical Code or NEC. The primary concern is ensuring that the overcurrent protection device, which is typically a circuit breaker or fuse, adequately protects the smallest wire in the circuit. The NEC mandates that the overcurrent protection device must be sized appropriately for the ampacity of the smallest conductor in the circuit. In this scenario, it's a 14-2 wire, referring to a non-metallic sheath cable with 14 American wire gauge conductors and 2 current-carrying conductors plus a ground, is typically rated for 15 amps. Therefore, if you were to use 14-2 wire in any portion of the circuit, the overcurrent protection device should not exceed 15 amps. Using a 20-amp breaker, as is the case with the existing 12-2 wiring, would violate this principle because the 20-amp breaker would not provide adequate protection for the 14-2 wire. If an overcurrent situation were to occur, the 14-2 wire could overheat and potentially cause a fire before the 20-amp breaker trips. Section 110.14. C of the NEC addresses the splicing of conductors of different sizes. While it does not explicitly prohibit mixing wire sizes in a branch circuit, it states that conductors of different sizes shall not be spliced together unless the splice is made by an insulating device identified for the purpose. This implies that you cannot simply splice a 14-2 wire to a 12-2 wire without using a connector or method specifically designed and listed for that purpose. The intention is to maintain the integrity and safety of the electrical connections. To elaborate further, when dealing with branch circuits, the NEC provides guidelines to ensure safety and prevent hazards. Mixing wire sizes can create a situation where the smaller gauge wire is not adequately protected by the circuit's overcurrent protection. For instance, if a circuit is wired with 12 American wire gauge or AWG wire protected by a 20-amp breaker, and then a section of 14 AWG wire is introduced, the 20-amp breaker might not trip quickly enough to prevent the 14 AWG wire from overheating in an overcurrent or short circuit scenario. The ampacity of a conductor is the maximum current, in amps, that the conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides tables, such as Table 310.15, B16, that list the ampacities of various conductors based on their size, insulation type, and installation conditions. For example, a 14 AWG copper wire with type NM insulation is typically rated for 15 amps, while a 12 AWG copper wire with the same insulation type is rated for 20 amps. Using these ampacity ratings, the overcurrent protection device must be selected to protect the weakest link in the circuit, which in this case would be the 14 AWG wire. When planning to add an exhaust fan to an existing circuit, several factors must be considered to ensure compliance with the NEC and maintain electrical safety. Firstly, assess the existing circuit's capacity and load. Determine the total load in the existing circuit, including the new exhaust fan, to ensure that it does not exceed the circuit's rating. The total load should not exceed 80% of the breaker's rating for a continuous load. Secondly, verify the wire size and overcurrent protection. Confirm that the existing wiring and breaker are appropriately sized for the total load. If the existing circuit is already close to its maximum capacity, it is advisable to run a new circuit for the exhaust fan. Thirdly, consider the location and environment. If the exhaust fan is located in a damp or wet location, ensure that all wiring and connections are suitable for that environment. Use appropriate enclosures and fittings to protect against moisture and corrosion. Fourthly, follow proper wiring methods. Use approved wiring methods and materials for all electrical connections. Ensure that all connections are made inside junction boxes and that all wires are properly secured and protected. In the specific case of wanting to add a low-amp exhaust fan that draws approximately 3 amps to an existing circuit protected by a 20-amp breaker with 12-2 wiring, it's important to ensure the new 40-2 wiring is protected. Since the 40-2 wiring is rated for 15 amps, it cannot be safely connected to the existing 20-amp circuit without additional protection. There are a few possible solutions. Firstly, running a new 15-amp circuit. This is the safest and most compliant solution. Run a new 14-2 wire from the electrical panel to the location of the exhaust fan and install a new 15-amp breaker in the panel to protect the circuit. This ensures that the 14-2 wire is properly protected and that the circuit meets all NEC requirements. Secondly, installing a sub-protected circuit. Install a junction box at the existing outlet and use a listed and labeled method to transition from the 12-2 wire to the 14-2 wire. Inside the junction box, install a fuse holder with a 15-amp fuse in line with the 14-2 wire. This will provide the necessary overcurrent protection for the 14-2 wire. Ensure that the junction box is properly installed and accessible for future maintenance. Thirdly, replacing the existing breaker. If the existing circuit serves other loads that do not require a 20-amp breaker, consider replacing the 20-amp breaker with a 15-amp breaker. This will protect the entire circuit, including the 14-2 wire, at the appropriate level. However, this option may not be feasible if the other loads on the circuit require the 20-amp capacity. In summary, while it may be tempting to tap into an existing circuit to power a new device, it's essential to ensure that all wiring and overcurrent protection meet the requirements of the NEC. Mixing wire sizes can create a hazardous situation if not done correctly. The safest and most compliant solution is to run a new circuit from the panel, ensuring that the wire size and breaker are appropriately sized for the load. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring. Additional considerations when working with electrical circuits include proper grounding. Grounding is an essential safety feature that helps to prevent electrical shock and minimize the risk of fire. Ensure that all electrical equipment and wiring are properly grounded according to the NEC requirements. Use appropriate grounding conductors and connections to create a low impedance path for fault current to flow back to the source. Also, consider arc fault circuit interrupters or size. A size are designed to protect against arc faults, which are a common cause of electrical fires. The NEC requires a size in many locations throughout the home, particularly in bedrooms and other areas where people may be sleeping. When adding a new circuit or modifying an existing one, consider installing an FSI breaker to provide enhanced protection against arc faults. Ground fault circuit interrupters or GFCIs are designed to protect against ground faults, which could occur when electricity leaks from a circuit to ground. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. When installing an outlet for the exhaust fan, consider using a GFCI outlet if it is located in a damp or wet location. Another aspect to consider is proper labeling. Label all electrical panels, circuits, and devices clearly and accurately. This will help to prevent confusion and make it easier to troubleshoot problems in the future. Use a permanent marker or label maker to create labels that are easy to read and understand. Think about future expansion. When planning electrical work, consider the possibility of future expansion or changes. Install additional capacity and wiring to accommodate future needs. This will save time and money in the long run by avoiding the need for costly upgrades or modifications. Also, when working with electrical circuits, it is essential to follow safe work practices to prevent injury or death. Always turn off the power to the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical circuits while standing in water or on a wet surface. Ensure that the work area is well lit and free from obstructions. When making electrical connections, use proper techniques and tools to ensure that the connections are secure and reliable. Use wire connectors that are listed and labeled for the specific application. Tighten all connections to the proper torque to prevent overheating and loose connections. Also, inspect all wiring and connections carefully before energizing the circuit to ensure that there are no exposed wires or loose connections. After completing the electrical work, test the circuit to ensure that it is working properly. Use a multimeter to measure voltage, current, and resistance. Verify that the circuit is properly grounded and that there are no ground faults. If you are not comfortable performing electrical work, it is best to hire a qualified electrician to do the job. Electricians have the training, experience, and tools to perform electrical work safely and correctly. Hiring an electrician can help to prevent electrical hazards and ensure that the electrical system meets all applicable codes and standards. Remember, electrical safety is paramount. Always prioritize safety when working with electrical circuits. Follow all applicable codes and standards, use proper techniques and tools, and never take shortcuts that could compromise safety. By following these guidelines, you can help to prevent electrical hazards and ensure that the electrical system is safe and reliable. In summary, the advice provided is for informational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other professional before performing any electrical work. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure safety. The NEC is a comprehensive set of standards that govern electrical installations. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations meet all applicable requirements. Many jurisdictions also have local electrical codes that may be more stringent than the NEC. It is important to comply with all applicable codes and standards when performing electrical work. Always verify that any products or materials used in an electrical installation are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. Listing and labeling indicate that the product has been tested and meets applicable safety standards. When working with electrical circuits, it is important to understand the different types of circuits and their characteristics. Branch circuits are circuits that supply power to individual outlets, lighting fixtures, and appliances. Feeder circuits are circuits that supply power to branch circuits from the main electrical panel. Service entrance conductors are conductors that bring power from the utility company to the main electrical panel. The size of the conductors in a circuit depends on the amount of current that the circuit is expected to carry. The NEC provides tables that list the ampacities of various conductors based on their size, insulation type, and installation conditions. The overcurrent protection device in a circuit is designed to protect the conductors from overheating and causing a fire. The overcurrent protection device should be sized to protect the smallest conductor in the circuit. Also, be mindful of voltage drop in electrical circuits. Voltage drop occurs when the voltage at the end of a long circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The NEC provides guidelines for minimizing voltage drop in electrical circuits. Remember that electrical installations should be inspected by a qualified electrical inspector to ensure that they meet all applicable codes and standards. Electrical inspections help to identify potential hazards and ensure that the electrical system is safe and reliable. It's crucial to understand the importance of electrical safety and the potential hazards associated with electrical work. Always take the necessary precautions to protect yourself and others from electrical shock and fire. Never work on electrical circuits while under the influence of drugs or alcohol. The information provided is not intended to be a substitute for professional advice. Always consult with a qualified electrician or other professional before performing any electrical work. Prioritize safety, follow applicable codes and standards, and use proper techniques and tools to ensure that electrical installations are safe and reliable.